Hello everyone and welcome back to another video where we have this fun little log integral from an MIT integration bee. This is actually one of the few indefinite integrals I've done on the channel. This actually might be the first. But no matter, let's just get started, shall we, with all the logs. All the logs, that's fun, lots of logs. What we're going to do to start off actually is do a substitution to get rid of most of the logs that I was so happy talking about. So we have u equals the natural log of x, right? And what this allows us to do is replace a lot of our integrand right here with x. So it's going to become, well, the integral now of 1 plus u, and then times 1 plus the natural log of u. And then we have to convert our dx into du, of course. So we have du equals 1 over x dx, but just moving the x onto the other side, we have this right here. So x du equals dx. And we can just solve for x real fast. I mean, it should be rather clear that this right here is just e to the u. Du is equal to dx just because x is equal to e to the u. You just exponentiate both sides. So we have e to the u times du right here. And what we're going to do next is actually integration by parts. And the reason we want to do that is because dealing with this term right here, taking the indefinite integral of e to the something, like e to the u times natural log of u, that's not very fun. We don't want to do that. And you also might just notice here that we actually can integrate this 1 plus u times e to the u right here. That we can integrate, the other term we can't. So we have the integral of 1 plus u times e to the u du. And by our formula for integration by parts, what we're going to do to take care of this is integrate this term right here, integrate this e to the u, and then also differentiate this term on the left right here. So what we're going to do is you always integrate first. So we're going to have e to the u and then times 1 plus u. And then we're going to have minus the integral of, well, whatever our integral of this was right here. So e to the u doesn't change, so it's still e to the u. But then we have the derivative of 1 plus u, which is just going to be 1. So we have the integral of e to the u du, which this might be the hardest integral we've done on the channel. I have to pull out the series expansion for this one. No, I kid. This right here is just going to be e to the u, 1 plus u, then minus e to the u. And then we're just going to subtract this right here because the one and this right here are going to cancel because you distribute that, you have e to the u minus e to the u. So this right here is just equal to e to the u times u. So we've taken care of one part of this integration by parts right here. We've established that the integral of 1 plus u times e to the u is just u times e to the u. We've actually covered this in a previous video where we took the nth derivative of u times e to the u, but anyway, it's like we're doing the reverse now, which is always fun. But focusing in on this integral, what we have now is we've done this integral bit, so drawing a fun little arrow. What we have now is u times e to the u, but then times 1 plus the natural log, that's an h, natural log of u. And now what we need to do is just take care of the second half of our integration by parts formula. So the minus and the integral of u times e to the u, well, we integrated, and then we need to differentiate this term right here, this 1 plus natural log of u, which really isn't too bad. That's pretty straightforward. We just, well, the derivative of 1 is just 0, and the derivative of 1 over u, or sorry, derivative of natural log of u is 1 over u, so we have times 1 over u du. And you'll see here that these terms do just cancel nicely, and we end up with the integral of just e to the u. So our final expression here is actually just going to be u times e to the u, and then times 1 plus natural log of u minus e to the u. But you'll remember here a couple of things. First off, that we said that our x is equal to e to the u, or in other words, our u is equal to the natural log of x. So we can just substitute everything back in here. We can just say that this here is now natural log of x, or x times the natural log of x, because we would get our x and then natural log of x. Then we have 1 plus natural log of x, lots of parentheses there, and then minus e to the u, which is going to be x right here. And one more thing, this would not be an indefinite integral if we missed the c. Missing the c would not be fun. So always add the plus c for funsies. So this was a shorter video than most of them, but I hope you all enjoyed. and I will see you all in the next one. Bye!